Hello, Portable for parents and students. This is a little quick movie about what will be on the first data management test. And it's basically on the first half of Chapter 3. So for grade 5s, that's Chapter 3, Section 1, all the way to Section 5. And for grade 6s, that's Chapter 3 in the textbook from Section 1 to Section 4. So here's basically some of the stuff that's on the test and highlighted in the pair in those sections. For grade sixes, they start off with coordinate pairs. That's when you have a value for an x and a y that you can plot on a grid. In terms of line graphs, there are broken line graphs and there are straight line graphs, both of which the grade fives and sixes should know. Line graph basically ends up being a nice straight line when you graph it because something is happening at a consistent rate, so the line goes up nice and straight. In real life, that doesn't happen too often, though. We tend to end up with broken line graphs where let's say we're measuring the temperature and it goes up and down in different months. And you end up with a graph that is a bunch of lines connected together rather than a straight line. The grade 5s have a small section on interpreting circle graphs, and the grade 6 have another section on scatter plots. In a scatter plot, you have a lot of data which you then graph, and then you try to interpret. And at the very bottom is also bar graphs with intervals, and I'll explain that today in this video. So let's say you have some data on, this is the score, goal scoring on a hockey team of a bunch of kids, let's say about 20 kids. And, they have different values. If you graphed each value individually, like how many scored 1, how many scored 2, you might end up with a graph of a lot of small little boxes, small little bars, and it's not always that meaningful. So instead what we'll do is we'll try to group the values into different intervals. So instead of 19 or 20 little bars, we'll end up maybe with 4 or 5, and maybe that'll be a little more informative for us. So the first thing you always want to do is identify what the high and the low values are in the goals in this case, so that we have an idea of what the range is. So for us today, we're going from 1 to 19, so the range is about 18 or so. So when you end up finding out the range, typically you want to put that into a nice round number. So then we can divide it up and figure out what our intervals are going to be. Well, if you're looking at 18, well, for a round number, you'd say that's about 20. Okay? Now we know our range is about 20 numbers. We have to kind of figure out how many bars do we actually want in our final graph. Sometimes I've seen 4, sometimes I've seen 5, sometimes we've seen 10. So it's kind of something that you have to decide yourself. In this case, I will say that we'll do 5 bars. So how do we figure out what the interval is going to be for the different bars on our graph? So our range is about 20, and we want about 5 bars or 5 intervals. So usually if I do 20 divided by 5, that little slash is divided by. 20 divided by 5 is 4. So my intervals are going to have 4 numbers in them. So I would do 1 to 4, that's one interval. If anyone scored 5 to 8, that would be the next interval, and so on until I get the whole range done. So these are the 5 intervals or the 5 bars on my graph. Then I go through the data and I start tallying how many people scored 1 to 4. So you can see at this point there are 3 red circles for 3 people that have scored. Now it's hard to do tallies on a computer, but the data looked something like this. So instead of a whole bunch of 19 little bars, I'm going to end up with 5 bars this time with the data all packed together. So again, I've done this on the computer, but this is kind of the end result, where now the data is grouped together, and I can see that the majority of people are scoring 9 to 12 goals on my hockey team. Now, just as a big hint, if you want to get full marks on anything, including EKO questions or my test, you're going to have to make sure that when you actually make a graph, that you give it a title and that you label the two axes, I guess. These three pieces of information are really important to let people know what the graph is about and what the scales are. Okay, now this is more of a grade 6 kind of a question, and it is a scatter plot question. In this piece of data, I've got somebody's height mixed with their weight. Now, I just made this data up, and I don't know if it's accurate or not, so I don't worry about that part. But in this case, with a scatter plot, when you've got this data, one of the really important or the hardest parts really is figuring out what should the scale be on my when I plot this on the coordinate grid. So let's take a look at my data. The high is 100 and the low is 63. So again, I start thinking about the range. The range in my data is 100 minus 63, which is about 37. The other thing I realize is that the numbers I have are between about 60 and 100. So I don't need to really graph the 50 or the 40 centimeters or 30 or 20 or 10. That part's not as interesting. I really want to focus on the range the range of numbers where I have some data, and I want my scale to reflect that. So again, if I'm looking at my range, I have 100. Take away 63 is 37. So again, what I normally do is take this range and change it into a number that's a little more workable. And to do that, I change that into a round number. So for 37, I'll say that's about 40. Now typically on a coordinate grid, you have about 10 or so boxes to work with. Sometimes a few more, but let's work around the idea of you've got 10 boxes to work with. Now you want to spread out this number 40 amongst the 10 boxes. So if I take 40, and that slash again is divided by 10, that means every little tick on my scale is going to equal 4. So that might look something like this. My first tick I'm going to start at 62 because my lowest value is, say, 63. Then I'm going to add 4 each time, and it's going to take me all the way up to 102, even though I only need 100. So this scale right now starts just a little bit below my lowest value and goes a little bit above my highest value, and it's divided in 4. When I plot this data, if I have a number like 62, well, I can use the line pretty clearly. But if I have like a value like 64, I'm just going to estimate somewhere in the middle there, between 62 and 66. You would do the same thing now for the weight. You would look at the range and, make that into a round number and try to sort that nicely on the y-axis. Right now I'm just doing the x-axis. Because we haven't started at 0, we usually draw like a little wiggly line in there just to show people that it didn't start at 0. And then you plot the data. I'm just making this data up, but let's imagine it looks like this. If you get this kind of a value, we say that's a positive correlation. That weight and height are correlated. They kind of influence each other. Doesn't mean they cause each other, but they're kind of related. If the data looks instead like this, we would say that has a negative correlation, meaning having a lot of one thing usually means having less of the other. And if the data was scattered all over the place, then we would say it's not correlated. The two things are not related. I think that's it. So that's a quick overview of some of the important concepts you're going to need to know for this test. Good luck.